Hi, this is Beaumont here. We're having a quick look at the unified modelling language concerning class modelling. So a particular type of model in the UML set of diagrams called class modelling. And if you know about ERDs, that's interrelationship diagrams, you'll see this is a logical extension. You can find lots of material at my website given below. Right, so why is UML so important? Well, actually everything leads really to UML. You think about designing clinical systems, if you think about the electronic healthcare record, if you think even about personal development plans, they can all be modelled and described by using UML. UML itself is based upon a particular philosophy of describing the world, and you find once you start using UML it makes you think about everything in the world in a particular way. It might be classed as a rather bad reductionist way, but I actually find it's an extremely good way of clarifying much of your thought about the world in general. So let's think a little more about this. How do we actually perceive the world? Well, we perceive the world as a set of things, and these things that we perceive in the world are actually conceptually distinct. We think about, an animal, a bear being different to a cat. We think of a glass being different to a microphone. We think of a window being different to a piano. Why? Well, basically it's because we think of these things as objects, and we think of objects as being of two types. Either classes, which are really templates for real world things. So a class might be a human being, a person, but then we have instances of that person, which is me and you. And so we say that the classes are templates and the instances are real world examples of these templates. It's not a new idea, by the way. Plato came up with this called Platonic realism, and you can look at that on Wikipedia. Right, so UML, Unified Modelling Language, is actually mainly to do with diagrams. UML people get very upset if you say it's a diagramming language. It basically is diagramming with some additional detailed syntax to do with interrogating databases added in, and some other things as well. So in a UML class diagram, the most basic thing we have in it is a class definition, and here is a definition for the person class. So we have in that top compartment the name of the class, which happens to be person, and then we have a set of attributes or data, and you can think of those two top compartments being equivalent to an entity type with attributes, if you know about ERDs. And then we have this additional compartment at the bottom, which is concerned with operations and methods, because we don't just think about characteristics to describe something, we always think about actions that that particular object takes. If you think about it, that's how we define the world. It's not just what it looks like, it's what it does as well. And the important thing is to realise what we define there is a template, is a class. So the person could be Robin, you, me, it could be a particular age, it could be a particular hair colour, they could be carrying out certain activities, but that is an instance of that particular class we're talking about there, whereas when we're just genetically defining a template, it is a class, not an instance. So let's have a look at some examples here now of an instance. So here we have an instance of a person called John, and that's where the attribute age equals 34 years, the hair has a particular value called brown, and we go on like that. You might help you think about this in terms of a table, and I put a table there at the bottom of this screen which is not part of UML, but it might help you understand it. So here we have a doctor class, and we've got three instances of doctor, and you notice there are attributes for that doctor class is surname, forename, date of birth, GMC number, salary and gender. And we can see there that the surnames are Smith, Coates and Worsley, and then we've got two operations also defined for those various instances, those three instances of the doctor class. So this way of thinking about classes and instances by drawing exemplar diagrams, or whatever you want to call them, I feel helps a lot when you're first starting out. The important thing is those exemplar diagrams are not part of UML, it's just me trying to help you understand this concept a little more. So let's look more about classes and instances, how they differ. Well, an instance can exist only if that class exists. So an instance is an example of class. That's why I like to call the word template as another way of describing a class, because a template is something that you make other things from. If you don't have a template, you can't make instances of it. But this doesn't work the other way around. You could have a class can exist, but there might never be any instances of it. And we'll look at this as an example later on, and why it's sometimes very useful to have classes where you don't have direct instances of it. Let's try some actual multiple choice questions, see how far we've understood what we've done so far. All my handouts, all PDF documents on my website have a large number of MCQs in them, and here's some typical examples. So the first one is, which one of the following is an example of a class? Robin Beaumont, carrot, dates book on my shelf at home, a spike from the TV series, or my backup disk? Well, we're looking here for an example of a class, not an instance. So we're not really looking for a real-world example, we're looking for something we can make real-world examples from. Well, I haven't been cloned, so I think we can rule out A, and we can refer to kind of A as being in the table that I started off before. So we have, if you think about it, Robin Beaumont has a name, a surname, a date of birth, a mobile number, and an email address. Well, that would be one row, Robin Beaumont, which would be an instance of probably something like person or mail or something like that. Similarly, if we look at the backup disk example there, that would also be one row in these idea of drawing the tables of instances. So we can definitely say that A and E are instances rather than classes. And we can do the same thing with C and D. But if we think about B, carrot, well, a carrot is really a template, because what we have is a carrot probably in bed 5, row 5 in my garden. It might have a particular variety, golden green, it might have a particular size and diameter, and if we work like eggs or what have you, we might even give each carrot we grew a particular ID. We wanted to follow and track it and find out if it was particularly sweet or sour. So definitely go for carrot there as an example of a class. So let's look at the next MCQ. Which one of the following is an example of an instance of a class? Course manager, health informatics courses, women, Tony Blair, or religion? Again, do the same type of thing, and if we think about it, the only one where we can have that particular descriptor I've given from F to J is Tony Blair, where it would be probably an instance of person or prime minister. Course manager we probably have as a class with sets of names in it. Similarly, health informatics courses might have a set of names as well. So I would definitely go for Tony Blair. Notice that we've constructed these instances and classes. The instances always have the same structure as the class. We don't have lots of fields that are empty, attributes rather that are empty for our instances. They're filled in with particular values, so they all have the same structure, all the instances for a particular class. Right, people often get confused about the instance and class differences with a kind of problem. You might say a male is a kind of human being, and that is different from saying a male is an instance of human being. And why is that? Well, there are subtle differences, and it's to do with structure. So if we actually model a kind of relationship by using a thing called inheritance, which we'll talk about a little later on. But the important thing is that each child of the parent is actually different in some way in terms of structure. So if we look down here at the bottom, we've got an example of first names, which are Mary, John, David, Philip and Anne. And we have a set of attributes: bra size, dress size, inside leg, date of birth and waist. Now you notice some of these are highlighted and some aren't. So for Mary and Anne, we've got bra size and dress size highlighted, date of birth and waist. Whereas for John, Dave and Philip, we only have inside leg and date of birth and waist size. So structurally they're different. So if we actually try to put them in one class altogether, we have lots of gaps for the males and lots of gaps for the females. So it's pretty obvious that really what we'd have is a supertype with two subtypes, and the supertype would probably be the parent type. That is, the supertype would have date of birth and waist, and then the two subtypes, the two children types, would be male and female, and they would have these additional attributes, which we'll look at later on how to do this in more detail. So the important thing to note there is it's actually bad to try and think of a class where you have lots of gaps in the attributes, and it's based upon a type of subset of instances. It usually means that those subset of instances which are got no values in a particular attribute should be an actual other type of class, another class. Right, interesting thing is that when we try to define classes, it's actually from very much a particular viewpoint. So the attributes and methods that we put in a particular class is related to our particular job. So if you think about it, a community nurse would define a very different set of attributes to a patient for patient class. Similarly, a GP, an anaesthetist, a daycare coordinator, or a paediatrician, and a psychiatrist would all define different sets of attributes and different methods for their patient or client class, or whatever you want to call it. They'd even probably have problems with defining what the terms mean, the names for each class. So that's why it's so difficult to design information systems that spread across multiple professions. Obviously, you have links between various classes. No class is an island unto itself, and these links are modelled by a thing called associations. So let's take an example of a very simple association. Here we have a person, which is a class, eats bananas, and banana and person are both classes. So we represent that in a UML class diagram with this type of line, and the 0 ... star means that 0 or more people eat 0 or more bananas, and a banana is associated with 0 or more people, so we can go both ways. And in associations you can either have it at the class level or the instance level, so we could actually reinterpret that as Sally, which is an instance of person, eats the banana, instance of banana on a desk. Notice there that we've converted a picture into a narrative description. Obviously you can walk the other way around. You can take a narrative description and convert it into a UML diagram. So here is rather a long narrative. A primary care centre consists of employees, clients, voluntary workers and students, blah blah blah. And then next paragraph, patients can either be registered or visitors. Either can see a variety of the above people. They may be seen for even individual or planned series of visits. A visit may be a group session, consultation, or one or more treatments. Each client's record has several aspects, blah blah blah. So we can take out various words from this narrative to help define our classes. So we have employees, clients, voluntary workers and students, general practitioners, nurses and patients, and record. Problems, visit, consultation. It gets a bit more difficult as you go down the line, because sometimes you're not sure which is actually a class or which might be an attribute of a class, and this you only gather by experience and drawing many diagrams and discussing it with various people. You never get a model perfect, even with hundreds of iterations. And the interesting thing, of course, is that this is a very short narrative here. In real life, this is much more complicated in the way I've started describing it here. But in UML, you convert this narrative to a diagram, and here is a class diagram representing some aspects of that previous narrative. And when you work through the Magic tutorials, you'll find that the first tutorial is concerned with drawing this UML class diagram. You'll notice that besides the simple association I described before, there are associations there with arrows, with filled in triangles, with oblongs, and they all mean different things, and we'll look at those quickly now. And all those associations are of different types, and basically you have 3 levels of a type of association. You have simple associations, ordinary associations, which is a one-to-many or a many-to-one, very similar to the ERD diagramming. Then you have additionally complicated type of association called an aggregation, and with aggregations you have what's known as the assembly and component class. So the component and assembly make up the aggregation relationship, the association. So an aggregation can be thought of as a consists of type relationship. Then the third type of association is what's known as composition. And in composition you have this idea of dependency. And a good example of that is person has organs. Well, how dependent are the person and the organs? For an organ transplant coordinator, the person and organs can exist separately. Actually, they want them to. They still want the kidney or the heart or the corneas to exist after the person has ceased. Whereas if you think about dependency, then the organs would be deleted or die immediately the person dies. So the way you define things is again dependent upon your personal viewpoint. Another type of association is that called recursion. And recursion is where you have one or more instances of a particular class that relate to other instances within that class. And a classic example of that is where you have an employee who is also a manager of other employees. So an employee can manage other employees, but they're both the same class. So you draw a line from and to the same class, which you'll notice in the previous diagram if you were quick. A lot more details about that on my website. And the last, most complex type of association is that called inheritance, which is to do with the kind of relationship. And here is an example of inheritance. Here we have a procedure which is called the superclass, the supertype, alright? And so procedure has 5 attributes: ID, name, description, available to GP fund holders and cost, and then 2 methods, and then it is associated with 2 subtypes. That should be, not supertypes. So one supertype relates to 2 subtypes there. And the 2 subtypes are inpatient procedure and day case procedure. How this works is that the inpatient procedure inherits everything from the supertype, superclass. Similarly, the day case procedure inherits everything from the supertype. So down at the bottom I've given you 4 examples of a day case procedure, and I've highlighted in yellow the additional attribute and method that it's got from itself, but it's also inherited all those other attributes and methods from the superclass, the procedure superclass as well. So can you see that you might actually not have any instances of procedure. It's actually known as a virtual class, but we only have examples, we only have instances of inpatient procedure and day case procedure. We just use procedure as an additional way of saving us specifying those attributes and methods that are common to both subtypes. There are lots of exercises in my UML documents for you to work through, as well as MCQs, which again you can find below at my website address. What we've covered there is the first type of diagram that is used in UML class diagrams, and there are a large number of diagrams, 14 or 13 or 14, and they're divided up into 2 main categories: those to do with structure and those to do with behaviour. Although everyone tends to think of these diagrams as being separate, all they're doing is presenting the same model from different angles. If you think about an architect might have an elevation from the top of a house, an elevation from the side, the front and the back. All these diagrams are doing different views of the same model, and that is why we use a case tool to try and define these models, because you need to keep track to be absolutely consistent between all the different diagrams you draw, different types of diagram for the model. So we're going to be looking at some other diagrams in next YouTube videos. We're going to be looking at UML use case diagram and a sequence diagram and a state diagram. You may ask why I've had these colours. Well, I've used these colours because Alison Hill did some research and discovered that this is one of the best set of colours for web screens. I hope you agree. Bye.